Hello everybody and welcome back. Root Beer here, your friendly neighborhood mathematician, and I'm looking at question at number 10, the very last question on our Manitoba Math Contest from 2019. So if you haven't given question number 10 a little bit of a try, I would strongly encourage you to do so before continuing on. Give it a try, see what you can make of it, see how far you get. It should, in theory, be the hardest question on the paper. Okay, requires a little bit of thought, a little bit of intuition, maybe a little bit of casework. I know question 9 required a little bit of casework there too. But let's see. So questions 8, 9, and 10 are usually quite hard. Hopefully question 10 should be the biggest challenge here. So we want to make sure we've actually tried it and see how far we've gone. Practice does make perfect on these things. What have we got? Question 10. No parts here, just plain question. Consider the equation ax squared plus y squared plus 4xy plus 2x plus 2y equals 0. Okay, that looks like generic sort of conic section. A, x, and y are real numbers. Okay. For every real value of x, there exists at least one real value of y. So no matter what x I pick, you can solve for a y. What are the possible values of a? Okay, so, if a is 2, there might be a way to make, no matter what x I pick, there might be a way to solve for y. But maybe if a is 12, it doesn't work. So that's what we're going to have to work out. Now, the equation itself looks sort of like a generic conic section. And so the 2x and the 2y at the end and the y squared in there is screaming maybe complete some squares. I'm thinking that might do the trick. But if I pair the y squared up with the 2y by adding a 1 to both sides of the equation and then turning it into y plus 1 squared, what's going to happen to my 4xy? I would need to pair it up with some y squareds and some x squareds to make a perfect square. And then we'd be doing sums of perfect squares being equal to 0, and it'd be similar to, what was that question on the paper? Question 14, I think it was? Or it's not 14, question 4? Actually, I want to go back and check. I'm regretting all this scrolling, but I think it was question 4. Yeah, question 4 with this sort of sum. Maybe I can make sums of squares equal to 0 or something like that. That's certainly an option. That's something that I'm considering here. That maybe it's the same sort of technique, and then we would turn it into a system of equations involving a's, x's, and y's. That's an option. But I don't like what would happen to my y squared. I'd have to sort of add some new things in. Well, I'll give it a quick try. But it's the 4xy. I mean, the 2x and the 2y, they're sort of demanding that you take these here. So y squared plus 2y. I'm going to add 1 here. I'm actually going to add 2 to both sides. I'm going to take an x squared and a 2x. And then we're left with plus 4xy and plus a minus 1x squared. So that could possibly be a square. But how do you get rid of the 4xy's? Well, you'd need to have some y squareds, some more y squareds kicking around. And I don't necessarily like that. You'd have to borrow another x squared from here. Then you'd have to introduce 2 more y squared, so you'd have 2 plus 2y squared. And you bring the 2y squareds over, and now you're subtracting squares. Got a bit of a hiccup there. It's not that this can't be done, it's just I don't know enough about A to want to do this, and I don't like that you have to add these squares on here just to get rid of this 4xy. Unless there's a bigger expression that I'm missing. What is x plus y plus 1 squared? Actually, I'm going to do 2x plus y plus 1. No, because that's going to... I need the x by itself and the 1 by itself to make the 2x. I need the y by itself and the 1 by itself to make the 2y. But I need something more with the x's and y's to make the 4xy. Yeah, I'll put a pin in this, but maybe there's another way to go about this. So we're told that, what was it? No matter what x I pick, I can always solve for y. So let's rearrange as a quadratic in y. And then that'll depend on x's and a's, and then we'll get the quadratic formula, and then maybe solving with the x's will depend on my choice of a. So we'll get 4x plus 2y, and then ax squared plus 2x. I don't know whether or not I want to factor that or something. Okay. So we know for any x there is a solution for y. Okay, but if there is a solution, it's quadratic, so we can use the quadratic formula. By our quadratic formula, y is negative 4x plus 2 plus or minus big square root. Let's draw a better square root as well. B squared minus 4. The a is 1, and the c is ax squared plus 2x. And this is, oops. This is all over 2a with 2, 1. So first thing I can do, I can actually divide this 2 out of here by getting rid of this 4, dividing by 2 inside this expression, dividing by 2 inside this expression. Right, because divide by 2 outside, you just divide by 2, but to divide by 2 inside the square root is really to divide by 4. That's why we get rid of the 4. But to divide by 4 inside a square is just to divide by 2. Okay, so we get negative 2x plus 1 plus or minus. I mean, I don't think I really needed to do this, but we'll get to do the dividing by 2, I guess. So we got 4x squared plus 4x plus 1 minus ax squared minus 2x. And so we got 4 minus a x squared plus 2x plus 1. So to have any real roots, the discriminant, that is, the thing under the square root sign, must be greater than or equal to 0. So 4 minus a x squared plus 2x plus 1, I think it was, has to be greater than or equal to 0. Okay. So that's looking nice, and we've gotten rid of the y's. Now we just have x's and a's. So I think this should be fine, right? Okay, what can we do to solve this, I guess? Now this is a quadratic in x. So this is a parabola. So I need to ensure that it's above or equal to, it never dips below the x-axis. Okay, so let's complete the square. Right, I think that should be the best thing to do. Yeah, I can't really... I don't think divided by 4 minus a is going to be the nicest thing, but okay. 4 minus a x squared plus 2 over 4 minus a x plus 1 has got to be greater than or equal to 0. 4 minus a x squared plus 2 over 4 minus a x, half of that, and then square it. You can't create numbers out of thin air, so we've got to do something like that. Okay, and then when you bring one of those out, you lose one of the 4 minus a's on the bottom. Okay, so we get 4 minus a, and then this is x plus 1 over 4 minus a all squared, plus 1 minus 1 over 4 minus a has to be greater than or equal to 0. Okay. So I can see 4 minus a, it's the leading coefficient. It's got to be greater than or equal to 0. So 4 has to be greater than or equal to a. Otherwise, parabola faces down. And then it would go, whoops. Oh, great, the computer's doing that again. I don't even know where we are anymore. All right, where was I? Okay, 4 minus. I hate it when it, I don't know, Drawboard PDF does that sometimes. It's super annoying when I'm trying to record. What was it? 1 over, no, it's plus 1 minus 4 minus a. It's got to be greater than or equal to 0. Anyways, the 4 minus a, otherwise you'd have a downward facing parabola. That's my point. So that means a has to be less than or equal to 4. Okay, so that's a good condition. But we also need the constant. So the k, this is sort of the h, but we need the y-coordinate of the vertex needs to be greater than or equal to 0. Okay, because the lowest this parabola will be is its vertex's y-coordinate. So you do that. Now 4 minus a, we just said, has to be non-negative, so we can definitely multiply by 4 minus a here without changing the sign, and that's kind of critical. So we'll have 3 minus a has to be greater than or equal to 0. So 3 has to be greater than or equal to a. And that seems to be the last thing I need to do. Okay, it's not really a combine these two, because a being less than or equal to 3 supersedes a being less than or equal to 4. I wish I could go back and review my answers, but as you can see, it's deciding to bounce around to just about everything I've written on this contest. So great. But 3 has to be greater than or equal to a is the last condition we really need to work with. Okay, so if a is less than or equal to 3, then that parabola in x will be facing up, and it will always be above or at the x-axis. So the discriminant will never be negative, so the quadratic formula will always produce a solution in terms of y for me, regardless of what x I choose. Okay, there we go. So that's it, and that is all they wanted, right? What are the possible values of a? Anything less than or equal to 3. Seems to be doing the trick. If you were a little hesitant, you could maybe, if you have time at the end of the contest, you could try something like, does 2 work, or does 1 work, or maybe like a -5, just to check it all out. But I'm confident in the math there that I haven't missed an inequality or anything like that. So there we go. Nice little Manitoba contest there. Good question 10. I liked it overall. I thought it was nice, clean, easy read all the way through. And not too many stumbling blocks there. So that's it for the 2019. If you're looking for any of the older Manitoba papers, in case maybe you're practicing for this year's coming up, I've gone through just about every one of them since, I want to say 2008, maybe. definitely, I have at least 10 years worth of the papers up there, and I'll always be doing more. The next one that comes out would be the 2020, so stay tuned for that. And yeah, thank you guys so much for watching. I'll see you for more math in the future.